Hello, ladies and gentlemen. I'm so happy I can be at your service throughout the video conference. This is Masoud Torabi. I'm a researcher, Iranian researcher in Isfahan Agriculture and Natural Resource Research Center. I'm scientific member board in research. So I would like to present my presentation entitled of Physiological Response of Iranian Alfalfa Ecotypes to salt stress as one of the deleterious impact of the climate change. Yes, salinity can be most a deleterious impact. Let me say that the climate change nowadays is the most important issues in the world and maybe the challengeable issues in the world. So it is important we be looking for some plants, animal, or whatever that can be tolerant and that can be adapting with the salt stress, or maybe as our view for the climate change impacts on the world. If we choose adaptation as a strategy for the just tolerant in front of the climate change, so we should find some germplasm or genotypes can be tolerant in front of the salt stress for something like this. And the adaptation, maybe it can be most cheap and effective ways to adapting to the climate change. For our view, let me say like this, maybe more than 6.5% of the world is affected from the climate change. And this is some experiment just already done about the salt stress, effect of salt stress on the alfalfa, and this is just some procedure to find some salt stress ecotypes, salt tolerance ecotypes, and it is some part of way just in front of the climate change. Let me introduce alfalfa to you. As I introduce of alfalfa, let me say that it is from Iran, Asia, a part of the Middle East, and before 2000 BS, just it was from the Iran, and something like 7636 just introduced to US, and they started for the breeding of the alfalfa in 1940. This is the map of Iran, and I choose my genotypes and my germplasm throughout the Iran from the six region of the climatic region. So this is my ecotypes. Just I done the experiment on these ecotypes. And this is from maybe 20 ecotypes. Just before I have some experiment during my PhD in Malaysia, and I choose these ecotypes. And this ecotypes is almost tolerant to salt stress. For procedure, I choose the hydroponic for my methodology, and I use of the hydroponic systems. So I started with the GP pad. I just planted the seeds in the GP pad, then I transferred to the pots, plastic pot, and I allow to the plants, just they reach to the maturity stage after 2 months, and after 2 months, I add the salinity levels as a gradually throughout the nutrient solution. And every 10 days, I increase the salt stress levels to 3 decibels per meter, and my sampling was in 3 stages, 6, 12, and 18 decibels per meter. You can see this is the plants before the salt stress treatment. It is very, very, very well grown and good condition. And then I go to the sampling and measurement. This is some instrument I use for the measuring. The first one is the SPAT calorimeter, and the second one is the plant efficiency analysis for measuring of chlorophyll fluorescence as a new factors of physiology factors for the evaluation of the plants in front of the soil stress or many stress. So this is Lycor. I use of this for the stomata conductance for photosynthesis, and also we can use of this for the almost 30 parameter of physiological parameter or maybe some physical parameters. You can see this is the condition of plants before the salt stress and before the treatment of the salt. This is good condition. And then we should go to the result. The first one, like you can see, this is the table of ANOVA, and you can see this is there is the differences between the ecotypes relative to the all parameters, including shoot, root diameter, ratio of the root shoot, and also photosynthesis rate, stomata conductance, and chlorophyll content, and also chlorophyll fluorescence. For the interaction between the soil stress and the ecotypes, only for the root shoot ratio and also stomata conductance, it was significant, but the rest is not significant. And for the salinity, all is significant and high significant. I can say high significant. You can see the relationship between the salinity levels and CGR in whole plants, root and shoot. With the increasing of the salt stress, the CGR, crop growth ratio, just decrease. And also, this is separate for the root and shoot. This is differences between the ecotypes. And ecotypes number 2 for root and shoot is most tolerant ecotypes because they produce, these ecotypes produce more shoot and root compared with the other ecotypes. You can see this is the differences between the ecotypes relative to the relation between the root-shoot ratio and also salinity levels. With increasing of the salt stress, the root and root-shoot ratio just, some of them is decline and some of them increase. And whatever is important, ecotypes number 2 just allocated more assimilation material to shoot when they just stand in front of the soil stress. You can see this is the relation between the photosynthesis rate and the salinity, just decline, and there is differences between the ecotypes. Also, this is for the stomata conductance. You can see with increasing the soil stress, just the stomata conductance just decrease, and there is differences between the ecotypes. This is relation between the CO2 assimilation and also stomata conductance. It is so clear, and also chlorophyll concentration just decline with increasing of the salt stress, and there is differences between the ecotypes. And the last one is for the chlorophyll fluorescence. With increasing the salt stress, the chlorophyll fluorescence just decline. But whatever is important, from first step of the salt stress to second step or stage, just the trend was constant. And after this, from 6 to 12, just the trend is not very sharp. The declination is not very sharp, but from 12 to 18 is almost sharp. And there is differences between the ecotypes. For conclusion, let me say something like this. The results have shown that a study of the plant's physiology response under salt stress can be led to an understanding of salt effects, and also response can be due to the osmotic and ionic influence, respectively, from as a short and long term of the effect, and stomata closing identified as the first step of the response, and after this, with stomata closure, the ratio of the assimilation rate just come down or maybe decline. And then another physiological parameter also is important for the declination of the CO2 assimilation, something like chlorophyll and chlorophyll fluorescence and chlorophyll contents. And the ratio of reduction can be due to the concentration of salt, environmental condition, and also plant stage growth. And the results have shown that ecotypes number 2 from north, the west north of Iran is Garaglu. The name is Garaglu. what's most tolerance in front of the salt stress. And it can be maybe, this ecotypes is from this very cold area, and maybe there is some relationship between the salt stress and cold stress. This is my recommendation to other researchers for the next researches. So with just this, my presentation in here is finished, and with hoping of the having a peace, clean, and beautiful planet. Thank you for your attention. Thank you.